Okay, speaking of transformation, let's take a look at a couple of examples with actual graphs. We're on page 27 of our note packet looking at example 1. Describe the transformation of the graph f of x equals to x cubed. That represent by g of x equals the quantity of x plus 5 cubed plus 2. So we're going from a parent function to this new transformation. So if I'm describing the transformation, let me write down the graph that I'm actually using. G of x equals to x plus 5 to the third power plus 2. There are a couple of things that we need to know. To go from the parent function, which has just the x cubed, to my g of x, the numbers that were added to the equation were the plus 5 and plus 2. And those two are going to tell me what transformation they are. According to the chart that we did earlier, the chart that's above, that plus 5, it's adding and subtracting on the inside just to the x of that group. So that means this is a horizontal movement. And since it's a horizontal movement, it goes against the sign, opposite of the sign. So this is really going to the left 5. It is translated left 5 units. And that plus 2, since it's added to the whole x cubed on the outside, it is going to go with the sign, and it is a vertical movement. Vertical is up and down. So since it's plus 2, this one is translated up 2 units. And that's how you describe transformation from a graph. And then it says to graph it. Of course, function f of x equals to x cubed. Let's do a quick table. So f of x when x equals to, let's say, negative 2. Negative 2. F of x is going to be negative 8. When x equals to negative 1, f of x is going to be negative 1. When x is 0, f of x is 0. When x is 1, f of x is positive 1. When x is 2, f of x is 8. Okay, with that, we can definitely graph these points at the from on the graph. Negative 2, comma 8. Sorry, negative 2, comma negative 8. It's right there. Negative 1, negative 1. So here, 0, 0, 1, 1, and 2, 8. So this is what a parent cubic function looks like. Okay, I'm going to take this parent cubic function and I'm going to translate it. So what I could do is I could do another table, right? I could do another table and call it g of x using the same x value and plug that in. I can do that. Or I can take the points and do left 5 units and up 2 units for each point. So if I were to take negative 2, negative 8, this point right here, I'm going to move left 5 unit, 1, 2, 3, 4, 5, up 2 units. That's my new point from negative 2, negative 8. Negative 1, up left 5 units, 1, 2, 3, 4, 5, up 2 units. There's my new transformation, new points for negative 1, negative 1. 0, 0, left 5 units, up 2 units. 1, 1, left 5 units, up 2 units. And then 2, 8, left 5 units, up 2 units is off the chart. So I can now connect those. This graph has been translated left 5 units and up 2 units from my parent function. That's a transformation right there. If you're looking at something that has a little bit more than just left and right, moving left and right, you can look at example 2. This again is the same graph from f of x equals to x cubed, so my parent function, to g of x equals to negative 1/4 times x cubed. Now that's a little, there's two transformations here. right? So let's describe the transformation first. The things that are added to it is the negative. Let me write down the equation. G of x equals a negative 1/4 x cubed. Notice that there are two things that are added to it. You got a negative right there, and you have just the 1/4. Both of these are applied to the entire equation x cubed. Both of these are applied to the outside of x cubed. So both of these are vertical movement. When I multiply by a negative, it is a reflection. Vertical reflection is a reflection over the x-axis. So that's one transformation. You took a point, flip it over the x-axis. Multiplication, it's either a stretch or a shrink. Since again, this 1/4 is multiplied to the entire equation x to the third, it is a vertical blank by, since it is outside, applied to the entire equation, that 1/4 stays the same by a factor of 1/4. Because 1/4 is between 0 and 1, this is a vertical shrink by a factor of 1/4. So that's my description. So when I want to graph it, f of x equals to x cubed. Remember that this is my parent function, f of x, right here. You can definitely do the same thing. Take the y value, reflect it over the x, and then multiply the y value by 1/4. So if I were to do this, I would take negative 8, reflect it over the x, so it becomes, positive y, when the 2, 8, 8, reflect it over to x, that becomes 2, negative 8. And then I have to multiply negative 8 by 1/4, so that becomes negative 2. That shrunk up to this one. So right here, 1, 1, reflect it over the x-axis, becomes 1, negative 1, and multiply it by 1/4, so that would be a negative 1/4. So real close to the 0. 0, 0 is going to stay as 0, 0. And negative 1 is going to flip over to positive 1. Multiply by 1/4. Again, it's going to be real close to that 0. And then last but not least, take the negative 8, flip it over to positive 8. 1/4 of that is 2. So this graph looks like this. It reflected over the x-axis, and it has a vertically shrinked. So it got closer to the x-axis. It got further away from the y-axis. And if you want to take a look at the horizontal movement, so we can take a look at example 2b. You have the equation from f of x equals to x cubed transformed to g of x equals to quantity 2x to the third power minus 3. So you got g of x equals to 2x cubed minus 3. The numbers that are added to x cubed is that multiplying by 2 right there. And then you got a subtract 3 on the outside. Since I'm multiplying by 2 on the inside, that's a horizontal movement. So I know it's a horizontal blank by a factor of, and since I'm doing the opposite, I'm doing the reciprocal on the inside, that's actually horizontal blank by a factor of 1/2. And since 1/2 is smaller than 1 and bigger than 0, between 0 and 1, this is a horizontal shrink. That minus 3 is on the outside. You're subtracting the entire x cubed by 3. So that is a vertical movement. And moving up and down, minus 3 is actually moving down. You're translating down 3 units. Those are my two transformations, and you do the same thing with the graph. Here's my parent function. this is a little tricky on this new one. When I'm looking at the new one, I'm looking at taking 2. This might be a good one to do a table on, because you have to apply the 2, multiply that to the x first before subtracting the 3. So let's go ahead and do a table on this one. This one might be easier with a table. I want some x values that gives me positive and negative. So I have, let's try -1. When I plug that in, -1 times 2 is -2. -2 to the third power is -8. -8 minus 3 is -11. So let's go, that goes down off the chart, 8, 9, 10, 11. So right about there. And then I have 0. 0 would be 0 times 2 is 0. 0 to the third power is 0. 0 minus 3 is -3. So 0 is at -3. And then there is 1. 1 times 2 is 2 to the third power is 8. 8 minus 3 is 5. So 1 comma 5. Okay, so connecting those, you kind of got a horizontal shrink. So getting closer, so further away from the x, you moved it down 3 units, so that 0 point now is down here. It shrinked horizontally, so it got squished closer to the y axis.